refrain from screaming.
Hello.
Hi, sorry.
No, that's okay.
That's all I did last time was just click that link, and it was able to get everybody in, so I don't know.
Either way, at least you got it.
Okay.
You guys.
Hello.
Okay.
So I wrote down the letters for the answers on the review questions, and I noticed on the quiz they're not in the same order.
Oh no.
So I'm having to go back and forth. Yeah.
That's annoying.
Mm-hmm. Well, let's just go. You guys all ready to start? I think everybody's here. Ellen's not coming, so.
Right. Yeah. Let's go ahead.
Yeah, let's go through it.
Lexi, are you with us?
Yeah, I'm here.
Okay.
All right. So
go ahead.
The first one was given a 90% confidence interval of 45 and 105 for mean heart rate. Which of the following is the best interpretation of this confidence level? And isn't it the 90% confident that the true mean heart rate is between 45 and 105?
The second one?
No, I think it's we are 90% confident, or we are not. Well, I don't know what you said. So
we are 90% confident that the true mean heart rate is between 45 and 105. So it'd be the second option in the quiz.
Are you guys doing the quiz or the study guide? Because the study guide, it's the first answer.
Right. No, we're doing
the quiz.
Quiz
has the same questions, but the answers are in a different order. So right. I'm actually in the quiz.
Right. I'm on the study guide, so let me open the quiz.
Yeah, the study guide was A, and this one looks like B.
Yep.
Yeah.
That would have made it so much easier.
They did it on purpose.
Yeah, it's all a conspiracy.
I opened 2 tabs, so I have both of them open so I can refer back and forth.
Oh, good.
Quiz. Okay. I'm good.
Perfect. Okay. Let's see. So for 3, I did the answer is yes. The distribution of the mean of each sample is normal since the data have been determined to be normal,
Yep, that's what I put.
That's what I
But
got.
I had too.
and that would be the 3rd answer.
Yeah.
Yeah,
Okay.
third
The
one.
numbers aren't even the same.
Nope.
No.
Ah,
Why would they make it easy?
Okay.
So the 4th one, you want me to read the 4th one?
Sure.
The 4 types of confidence intervals listed below. Which one is appropriate for this experiment? And I put the 3rd one, confidence interval for the difference of means using independent samples.
that's what I had.
So,
So
yeah.
independent because the effect, right, because I can't think of the word, but because they didn't depend on
Right.
each other, the female and male, they were just random.
Yeah.
Yeah, one did not determine the other.
That's what okay, perfect. Okay, I just want to make sure I'm
So it's
understanding.
the third on number 4. It's the 3rd one down, right?
Yes.
Okay.
Perfect. Okay.
So for the next one, they're not the same numbers, but
No.
I think they're just one off, right?
Yes.
So number 5, a researcher is interested in estimating the savings. I put the 2nd one, obtain the balance of 90 bank customers rather than 30.
That's what I was thinking.
Right.
That's what I put too.
Perfect.
Yeah.
Okay.
So
Percent increases the margin of error, right? The more confident, the greater the margin of error is going to be.
right, so if it was 99 instead of 95, is that what you're talking about?
Yeah.
If we chose that one? Yeah, that's right. I was actually going to ask the question because I couldn't remember, but you're exactly right, I think. Agreed, guys? Yeah.
If we were to compute 99 instead of a 95, the confidence level would get larger.
Right. Right. So had it been reworded and had it said compute the 90 rather than the 95, then that would have been the answer because that would have created.
Right.
But because obtain the 9 balances of 90 bank customers increases the number of sample size.
Okay.
Okay.
All right.
Cool.
So it's obtained balance of 90 bank customers rather than 30, right? Because
That's what I put.
yeah, because the more we sample, the more fine-tuned we can be.
Right.
Yeah.
Mhm.
Okay. Perfect.
Which on the quiz, that's the last one.
Yeah.
Yes.
Okay.
Okay. So I'm gonna need to be walked through on this one. I think I got it, but I might want to go through it.
That's fine.
No problem.
Okay. I'll read it then. A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts and put your answers for the margin of error, lower bound and upper bound.
Wait a minute.
Which
Margin of error 1.960. Is that what it is?
Are these out of order?
no, in the preparation assignment, it only asks you to find the confidence level.
The confidence
ask
interval.
Find the margin of error. So
Right.
this one added some stuff.
I thought I had this all figured out.
So
Okay.
the margin of error is, I gotta get my spectacles out because I wrote it down, but it's tiny because that's all you
To
can
fit on one page.
Yeah. So it would be 1.96 times 2 millimeters divided by the square root of 4, which is 2, right?
Right.
The 1.96 we got because that's associated with the 95%, right?
Yeah,
Right.
you have to go to the applet. You have to put in the 0.95, and then you select the middle section, and that'll give you a z-score of 1.960, right?
Yep.
Or actually, that's those ones we had to memorize or write down. If it's a 90, it's 1.645. If it's a 95, it's 1.96.
Right.
It's 90.
He was just saying, he was showing how you could find that as well if you didn't memorize it.
Right.
But so then you take the 1.695 and multiply it, or is it
No.
divide it?
Then you
1.96,
multiply it by 2 divided by the square root of 4.
which is 2, which is 1. So the answer, you said, Lexi, was 1.960.
Well, I didn't do the math. I was confused, but that's what I said.
That's
That's what I have as the answer.
Yeah.
Can
But it's
get
not
that.
always going to be that confidence level decimal, right? That's just what it happens to be this time.
No, if it's a single whatever, what is this? One sample t-test, it would be that every time.
Oh. Okay. But so what you did was the 1.960. So you do the, what is it called? The confidence level times the standard deviation divided by the mean is what you did?
The z with the asterisk times the standard deviation divided by the square root of the sample size. The square root of n.
I'm trying to find where I wrote this. Oh, I found it. Okay. I had to find in my notes. All right, so it is 1.960.
Yes.
Perfect. And then it wants the actual interval.
So the
Which-
1,000 minus 1.960 for the lower bound.
Hold on. Because when I punch it into the one sample t-test, I get a confidence interval of 996.818.
Well, this is a z, not a t, right?
because we just did the z test.
Oh, so this isn't a. Hold on, that's where I've messed up.
Because the standard deviation is known as a z, right?
Yep, you're right. You're absolutely right. So this would be. Which one is that on?
I don't know that we have one for
Oh,
that.
that's not a. That one we just have to do by hand, right?
Yep.
So then we would just subtract it out, then, right? So
Oh,
1,000 minus 1.96.
yeah. So the lower bound is 998.04.
That's what I had.
Yeah, that's what I have as well.
And then the upper bound is
Yep.
1001.96.
That's what I had.
But I have two.
If the whole class could just be this kind of math, it would be easy.
If I could take the test with you guys, great.
That would be awesome.
Yeah.
I have the one page of notes again. I haven't even looked.
Yes.
Yes, you are, and use it.
Okay, I'm gonna write tiny.
Right? Small.
Yeah.
Get a bigger page.
Yeah. Buy a poster board.
Okay.
I can read the next one.
I'm
To
gonna need.
accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weightings is computed. Suppose the scale readings are normally distributed with unknown mean mu. Is that what it's called? Unknown mean
Yep.
and standard deviation
Theta, I believe.
theta. Okay, that's what I was going to say. Okay, standard deviation theta of 0.01 grams. How large should the sample size be so that a 95% confidence interval for mu has a margin of error of plus or minus 0.0001?
So I have I know the have the formula for that in front of me, but I couldn't figure out what each part of the formula was to figure out the answer.
So this is that z-score again, the 1.96. So n equals
It's the 1.96
times theta
Which is-
divided by the margin of error, and all of that is squared.
theta, which is the 0.01.
You divide that by the 0.00001.
So
Okay.
is it 196 squared? I don't have a
No.
calculator that can do the squared right now.
No, it's 1.96 times 0.01. Then you divide that by 0.0001.
Oh, maybe I multiplied it.
Which equals 196, and then you square the 196.
Okay, yeah, that was my question.
So 38,416.
Yep, that's what I got.
That's what I had.
38,416. Yep, that's okay. Perfect. Yep. That's what I had too.
Okay. So
Wait, 38,416. Yeah. Okay. Yep.
416. Yep.
All right.
Okay, you want me to read the mean of mu of the several thousand apartments in a new development is advertised to be 1,200 square feet, 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis are...
Wouldn't it be the
I
last?
I had the null down as mu is equal to 1250, and the alternate is mu is less than 1250.
That's right.
That's what I had. That's the last one, right?
Yep.
I don't know. I haven't looked yet. Yeah.
Yeah.
There's the first one on mine. All right,
Okay.
last one.
Well, yeah, on the review, it was the first one.
Yeah.
Bunch of nonsense.
Yeah.
Okay.
In a, st-
Yeah, go ahead.
in a statistical test of hypothesis, we say we reject the null hypothesis with the level of significance alpha if it's the second one. If the
So it's
p-value
less than, right?
is less than alpha.
Hey, that's the same as those on the test, isn't it?
Sure.
Yeah.
Yep.
It got back to normal.
There you go.
Yep. Okay,
It's one
yeah.
of
So this is
random
actually worded different than the one in the review. The one in the review I feel like was worded weirder.
Oh,
It said
yeah,
the-
you just statistically significant, which I had to look up.
Yeah.
Yeah, okay. So rejecting the null, the p-value will be less than.
Yep.
Always and forever, right?
Yep.
Okay.
Yep.
Got it.
If it's less than, we reject.
No.
Okay, we're on 12. Group, yeah. I'll just read. A group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question? I said yes.
Yes.
Yeah.
And it's enough that the data are bell-shaped
Yep.
with no outliers and sample standard deviations are nearly equal.
Perfect.
That's what I had.
But I thought that ANOVA tests that the requirement don't they have to be right skewed, not bell shaped?
No, they have to be normally, but you have to check it with a QQ plot.
Right.
But the
The right skew.
result, the I'm not sure exactly what you call
So
it.
the F distribution has to be right skewed, but the data has to be normally distributed.
That sounds right. Yes.
Oh.
But I guess the question is, yeah, so the data will be normally distributed, which means it's bell-shaped technically with no outliers. But but you're right. The F distribution is right skewed.
I see. Okay.
So hopefully they don't get all tricky about that on the test.
Right.
Okay. That's really long. I said it was a type 1 error for
I did
third.
too.
So did I.
Yeah, that's what I got.
Because if they reject the null and they shouldn't have, that's a type 1 error.
Right.
Yep. Rejecting the truth.
Read the next 14.
Go ahead.
If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? This one I have by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
That's what I had.
Yeah, so that's the last one or the first one.
The first one.
That'd be the first one in the quiz. Yeah.
Yep.
And then for 15, wouldn't we reject the null?
Yes.
Oh, how come I have? Okay, wait a minute. What did I do wrong? How come I have failed to reject? Okay, what did I do different?
Well, so I think it
What's your
says
P
that.
score? Oh, wait a minute. My P score is really low. I think I just wrote the wrong answer.
Point
I have P score of
0.040.
.0031, right?
What?
Sure.
To be honest, I didn't even do the math for it. I went off of the mean.
Yeah, it's reject. I circled the wrong one.
Okay.
Wait, did you guys just plug it into?
How did you guys get your answer? Because I just kind of.
I had to find the z-score. Then you have to do the. See what they do. Oh, wait a minute here. Hang on. Let me look at this again. I should have
So
wrote my formulas out. Okay, so here's how I got the z-score.
known standard.
I went z
deviation.
equals 1.5. Okay, it's z is equal to x minus u divided by sigma minus the square root of n. Does that sound right for a formula?
Hold on.
And then so I got my z-score by going z is 1.5 minus 1.53 divided by 0.17 minus the square root of 100.
Oh.
Yeah.
That
That's,
would be the right
And
formula.
then so my z, I got negative 0.03 divided by negative 9.83, which gave me a z-score of 0.031. Then I plugged that, I'm going back to my original answer. And then I plugged that into the applet, and you put the 0.031 in, and we wanted greater than, didn't we? So I only shaded to the right, which gave me a p-score of 0.4988. Which now I'm back to, yeah, we reject because it's higher than 0.05.
right.
Does that all sound right?
We failed to reject.
Now I still think it's
If it's higher than 0.05.
yeah. Fail to reject. Sorry. I still
So
circled the wrong one. Yeah.
so you're
what
saying that your T is
There
We
is no
didn't
T.
find a T,
There
did
is no T.
because he just did the Z on this one.
well, when I was going through writing these notes down, it didn't ever show a Z score for that. It showed a T score showing X bar minus mu over the standard deviation divided
But
by
if the standard
square root of
deviation
n.
is known, it can't be a T. That's the whole thing about T's, is it's for an
Right.
unknown standard deviation. So it has to be a Z.
Okay, so tell me that formula again.
I didn't write it very neatly. I think it's Z equals X minus U divided by sigma, standard deviation, minus the square root of n.
Well, sigma divided by the square root of n, right?
Yeah, it's probably divided. See, I can't read my own writing.
That's
you for
okay. Yeah,
correcting me.
sigma. It's the sigma divided by the square root of n.
It's like I got scribble notes all over this thing.
So it's the same formula for that t-score, except
Yeah, just
yeah.
instead of
Okay.
They're all
S,
pretty much the same.
sigma.
Yeah.
So
I didn't think of that. So I'm gonna, if you're okay, I want to go do this just because I'm not there. I did something else and I obviously got the wrong answer. So
Okay, so what's the p-score on this one?
applet though. Because if you open the quantitative inference procedures and go to the one sample t-test tab, it
Yeah, but-
has a place for mean, standard deviation, and the sample size, and then it'll calculate it for us, right?
if it's a t-score, we can't use that for a t-score.
But if it's the same to calculate the
I think it might actually work.
same formula.
Because that's how I got mine, but I got 0.040 for my p-score.
Yeah, that's what I got. Wait.
Wait, what did you guys get when you did the formula?
Hold on, maybe that's a different question.
Because it's 1.53 minus 1.5 divided by 0.17. Oh, and the square root of 100, so it'd be 0.17 divided by 10. So 0.03 divided by 0.017, and I got like 1.765.
Yeah, I got that too when I worked it out.
Which would make the area to the right 0.039, which is 0.04, which means it's less than, which means we reject the null.
Yeah, but then what you're saying, if what you're saying is right, then you can just plug it into that applet because the p-value on the applet is 0.040. Or the p-value, I mean, that's the answer that I got with using it. Do you see what I'm saying? Like
The other applet, like the t distribution applet.
the quantitative inference procedures, and you open the one sample t-test tab. And then in that top box, it says summary statistics and has a place to put in the mean.
Oh, and you can enter in all that stuff. You're so right. And
It's still small.
I'm
Right.
just saying it's the same answer.
I think it was. I think you could do that, but either way, the answer I got is different than the one you got, Scott.
I know, that's fine. You guys got to straighten me out here. What do you guys have as the z-score?
Okay, so I did
1.76.
1.53 minus 1.5 divided
Well, you got those
by,
numbers. You're flipped from what I've got.
well, because you're supposed to do the mean minus the
Mu.
Yeah, I do it backwards.
Yeah.
yeah,
Well, that would explain it then.
because the sample mean minus the mean that they had. Yeah.
Chloe, did you get 0.0392?
I got in the applet, I got
Yeah.
0.039. Mine says 5, but yes.
Okay. So for your z-score, you get 1.76.
Yeah, yep, 1.756, yeah.
Oh, 756. Because mine's 1.76.
Oh, yeah, no, yeah, 1.76. You're right. I'm sorry. I was looking at something else. Yep.
Okay.
0.0392. Yep. Which would make it, if you round it, 0.04, which is less than 0.05. So we do reject the null.
Okay. Well, I'm glad we worked through that.
Yeah.
Scott, you got us on the right track.
No,
Yeah,
absolutely. I had
the
totally
numbers
guessed.
flipped.
Yeah.
But did we conclude then that you can use the one sample t-test for means?
Well, I entered in the stuff, but my p-value just shows a 1.
Well, did you change the null hypothesis to be 1.5?
I did not. I did not. And then it has to be equal to, right?
No, greater than.
It is greater than? Okay.
Yeah.
So for that, well, I still got well, I got 0.421, which is different than the 0.03, whatever it was.
Hold on. I'm trying to extend my thing. Because I got 0.040. So did you delete all of the data in the variable column?
Yes.
I don't think I did. Let me look really quick. I'm just going to start over with this. Okay. Mean was 1.3. Standard deviation was...
Yeah. I get the same as you did as 0.040.
Oh, I had something entered in wrong. I'm sorry. Hold on.
So it's
I
kind
did.
of
Yep, it is 0.040, which is what we...
a thousandth of a decimal off.
Yeah.
Still gets
Which
us.
hopefully wouldn't make that much of a difference. But yeah, if you had done that, you could have gotten the same answer that we did.
So, but when you guys did it by hand, which applet did you use? Did you use the T probabilities or the normal probability?
I just used the normal.
Normal.
Yep.
Okay. Goodness. The amount of thought. Okay. Normal. I gotta write this down.
That's my problem is I get it while we're talking and then I'm going to take the test and it's going to be gone.
That's exactly what happened to me last time. Like, I felt awesome when we were doing it together, and then I went to take the quiz and went,
Like, I almost need to go take it right now, right after we get off and just get it done.
yeah.
So the way we solved it was
We went through the formula. We found the z-score, entered it into the applet, and used the area as and compared the area to the level of significance.
right. So the formula that you used was the
The same one that
minus mu over sigma divided by the square root of the number.
Yep.
Yep, of the sample, yep.
Okay. And then you plug that into the normal probability applet.
Yeah, you just got to make sure you select right, left, or both, depending on what you're looking
Right.
for.
Okay. All right. I'm caught up.
Perfect. Okay.
Wait, so the answer is reject. The null
Yes.
hypothesis.
Yeah, the answer is reject.
Okay.
16.
It'd be a NOVA, right?
Independent sample test.
Right.
T-test.
Oh, because it's just the two. It's not more than... Okay. Okay. You're right. You're so right. Selected the wrong one. Okay.
And 17, if it's dependent, and if you pick a brother, you got to pick a sister too.
That's what I had.
Hang on, guys. So I'm still back on the last. So reject the null is the last one. Reject HO, right?
Yep.
And the next one is independent samples test, right?
Yep.
Yep.
Independent sample t-test. Okay,
Yep.
sorry. I was still playing with my spreadsheet to figure out that
No,
last
you're
one.
good.
Okay, all right, I'm caught up.
Perfect.
Okay. So 17, then we went dependent sampling. If you select a brother, so as to compare his academic achievement to his sister, you must include the sister in your study.
Right.
That's what I have. God, I wish the numbers were the same.
So
Okay.
we're on 15 in the review.
In the review, but it's 18 in here.
Yeah.
And
so it's the first one. Confidence interval for mu and theta is known.
That's right.
is known or unknown?
Unknown.
Unknown, sorry.
Yeah, I had
said it
unknown,
wrong.
yeah.
Okay.
Unknown. It's the first one.
Okay. Oh no. We did it again. We have to do the margin of error. Okay.
I'd have
So
done better
this-
notes.
This one, well, they didn't have us do the margin of error on the other thing.
No. Yeah, they're
So
They're
which
difficult.
thing are we looking at? The dissolved organic whatever?
yes.
So there's only one sample.
So do we use the one sample t-test for means?
I think so.
Okay.
The null hypothesis.
Oh no, what was the name of this thing? It's the dissolved organ, that's right.
Oh yeah, so what is the
What is the null?
Well, I know what the low and high was because I already entered it in once. Let's do that.
Yeah, we could just find the middle of the two numbers.
I think you could, right?
Yeah, you can. You don't want to do all the math.
So it's 11.168 and 15.217, right?
Right, that's what I had.
So then all we'd have to do is subtract that out.
Okay. That would be. So I would just take the 15.
So it'd be 2.025.
Yes.
Did you just subtract them from each other and then divide by 2?
Mm-hmm.
Okay.
2.025, right?
Yes.
Okay, I'm going with that.
2.025.
Yep.
Right?
Yes.
That's what we're
So I'm trying
doing.
to figure it out for real. I'm like, oh, okay, all right.
Did you figure it out for real? Because I can't remember how to do that.
We did it
Yeah.
earlier, but I just don't want to do it again.
Oh wait, the margin of error. That was that formula where
You did the 1.96 times.
theta
Yeah.
divided by m.
Yeah.
So what do we get?
For this would be what?
Okay, so
Oh, so that's where we have to use that thing is to give us theta.
you
Which
have to get
is-
the Z or the T score or whatever it is, right?
Yeah, so it's the standard deviation is 4.326. So we'd have to plug that in there. Divided by square root.
Of 20, right? Yeah.
1.896.
That's different than what we had.
No, that's not what we had.
Okay, hold on. Okay, so from when we did the margin of error earlier, we found out the Z score. We used the 1.96, but now we have to find out the T score first before we did that, right?
Yeah. T won't necessarily be that number.
Okay.
Yeah, it won't necessarily be that.
The T score was the mean minus mu divided by S divided by square root. No, you guys, I'm sorry.
Okay. Too many things going on here.
Okay, so I do have a question on this then.
What the?
So if we p-value is super small. Wait, are we less than or equal to on this one, or greater than?
4.326. equals. Wait, so what would be considered S then in this equation?
The standard deviation on this one? Well, I plugged the numbers into the quantitative inference procedures, and that's where I came up with the standard deviation of 4.326.
Right. So I guess my question is in the formula to find out like the t-score, it's the mean minus mu divided by s divided by its square root of n. So where are we getting those first two numbers? Like, what are we comparing?
Exactly.
Oh, so no one else gets that too. Okay.
Yep, I don't.
I'm a little.
So like in that.
Too much on my screen.
Guys, are we still trying to figure out number 19?
Yeah.
I think
Okay.
so.
We decided to go back and make sure we knew how to do it, and it turns out we don't.
But the way Jimmy does it works every time, right?
Well, it does every time we've done the quiz, but then when I do the homework on my own, I always get it wrong. So
Okay.
either I'm not understanding or for some reason it works in the quiz and it doesn't work every time, you know?
Well, and like I did after our conversation last Thursday, I went and subtracted it out, and like it didn't work. Like it wasn't right. Like there was some rounding
have to.
problems. So
Yeah, you have to find the difference.
Yeah, we have to, I think. So up here in our notes, it says margin of error is calculated by,
hold on.
the margin of error always, according to lesson 10, always uses the z-score.
Okay, hold on. We are going to do some simple math. If you're on the one sample t-test for means,
Okay.
which is what we're looking for, it
Uh-huh.
gives you the confidence interval, correct?
Yes.
Then, so take the high one and subtract it from the mean.
Right. If you have those figures.
Right.
Wait,
Which
so
would be 2.025.
just the 15.217 minus 13.193?
Mhm.
Because the margin of error is the distance from the intervals,
Right.
from the mean.
So
or the mean.
2.024, right, is the margin of error.
Oh, I had 0.025. Let me try again. Maybe I
I don't
did.
know. I didn't even bring a calculator to my desk because I thought this was going to be easy.
Failed you.
Yeah, no kidding.
So
I
based
got
on-
It's
0.025.
like, gee.
Oh, well, if you round it, so it's 2.0246.
how are you getting extra? Because the confidence interval it gives us on the things only.
Well, you had 0.024, so I went up to the thing in the spreadsheet and added another decimal to see if that's where you were getting it. But when I have only 3 decimals, it shows me 2.025.
I got 2.021.
Then something is not right here. 1.5.
Did you put 1.5 in the null hypothesis?
Oh, what?
Me or Chloe.
Either one of you.
I did.
Well, but that doesn't change the confidence interval or the mean. That changes the p-value,
Oh,
And-
yep, you're right.
but that doesn't change the confidence interval or the mean. Oh, this tells you the t-score.
Yeah.
Yeah, but that's not for 95%. That's for 100%. So you got to put it in the applet.
Well,
To
it
get
is
the
for
right-
95% because in the test it has it at 95%, right?
Sure.
guess
Try it. Try it. Do it. But the problem we still have is you don't have a x bar minus mu to subtract.
Yeah,
So I
that's
think
my issue.
from what I can tell that's I think the right way to do it is you take the high confidence interval and subtract it from the mean.
Okay, so it's not the upper minus the lower divided by 2. It's the high minus the mean.
Yep.
I mean, we got the same answer either way because that's what
Right.
I already had in there, but
Pretty much, yeah. Okay, moving on.
yeah. I'll just miss that question.
Well,
Okay.
I'm going.
Okay.
What's happening?
7.
So for the next one,
So we're on 22 now then?
Oops. Yes, which is 17 in the review. And this one is, oh, it's for the Hummers. Wouldn't that be independent samples?
Yeah, so confidence interval for the difference of mean using independent samples.
That's what I had. Yeah.
yeah.
Because you're independent because if you know one, you don't know anything about the other one. It's just
Right.
Yeah, that's right.
dependent.
No, independent.
Independent.
Okay, good. That's what I put.
So the lower bound, I got negative 423.
Me too.
Okay, sorry, you guys. Hang on. Hang on.
Yeah,
Determine the margin of error. Okay, so that was, sorry, I'll get there. 2.025, margin of error, right? Lower
That's what we're
bound
doing.
was 11.168, right?
Oh yeah,
Yep.
Higher bound, sorry, 15.217, right?
Yep.
All right, and then this one is the one that's confidence.
independent.
Yeah, independent samples, right?
Yep.
Independent samples. Third one down, right? Okay.
Yeah.
All right. Sorry, I got it. I figured out the T thing, but anyways, okay.
So in the review it didn't ask for the decimals, so I don't have the decimals written down. Does anybody else?
yeah, 423.238.
Okay.
Wait, that's the lower bound.
Yep.
Yeah, that's the
negative.
lower
It's
round.
a
It's
negative.
negative
Yeah.
423.
And then the upper, did you get 5417.336?
Yep.
What was the decimal on the other one? 4.23 point what?
238.
It's a negative though.
Yeah, 238. Okay. Yeah, I just circled the answer and didn't write down anything else. Crazy test.
No, really.
All right, because
Next time I'm just going to do it on the quiz.
I hate the amount of stuff we have to download.
I know. Okay. 25 is ANOVA, right?
Yes.
Yep.
Okay. Test statistic, I had 7.978.
Yes.
Can you say that again? Sorry.
7.978.
7.978.
Mm-hmm. P-value.
0.002.
Yep.
Yeah, that's what I got.
Okay.
002.
Yes.
Mm-hmm. Make sure these are worded the same.
Yeah, no kidding.
There is insufficient evidence to conclude that the bone density of at least one group is different from the bone density of at least one other group.
Yes, that's what I had. The second one down in the quiz or on the homework.
Oh, the second one
Right.
down.
Wait,
There is
That's what I'm talking
sufficient.
about. It's this. They worded it weird.
The sufficient evidence to conclude the bone density of at least
Basically,
one of the
we
groups is
rejected the null because it was less than. Correct.
no. Yeah.
Yeah.
Right.
And the null.
States that
They're-
they aren't different.
Right.
So
So-
that is sufficient evidence.
It's the last one.
Am I off again?
The last one. Sorry.
The last one.
The second to the last one is the right answer on the
Second
Okay.
is the last one.
Are you talking about on the computer or on my paper?
on the quiz.
On the quiz,
Yeah,
the
right.
second
On
to
your
last
paper.
one.
On your paper, it should be B.
Yeah, right. Exactly. Got it.
Sufficient evidence to conclude that the mean bone density. Okay, hold on. Question. So is that the null hypothesis that's stated at the end of that?
No,
No,
that's
it's-
the alternative.
It's
Okay.
always.
True, sufficient, or insufficient, and then state the alternative.
Yep.
Yep. Okay. Are we good on that one?
Yep.
Yes.
Okay, this one,
Dependent sample test or matched pairs.
that's what I had.
Yep.
That's what I had.
Yes.
Okay, test statistic 1.685.
Yep.
P-value 0.096.
Yep.
Guys, I'm hoping this test is a little easier than the last one.
I don't think it's going to be.
I don't either.
I actually did pretty good on the last one, and I'm totally gonna fail this. It's gonna be bad, guys.
I'm
Okay.
putting a poster board.
Yeah.
With
Right.
everything on it.
This one
Okay.
is sufficient to conclude there is a difference.
What I'm talking about. Okay. The p-value is 0.096, which is less than 0.01, so we reject the null,
Yep.
0.
which the null was that
They're the
they
same.
were the same. So we're saying that there's evidence that they are different.
It was B, right? Or the second one?
Yeah. In
Yes,
both,
there's
actually.
sufficient evidence to conclude that there's different meaning. Okay.
Yeah, on the review and the quiz were both B on that one.
All right. I'm gonna save and submit.
I submitted mine.
Did we fail?
We missed half of them.
Oh no.
Get them all right.
We got it. Okay, so we got that margin of error question
Oh my
right.
gosh, when you said we missed half of them, I thought you were serious.
Sorry.
Oh my god.
I mean, the
She
margin of
panicked.
error, you subtract the mean from the high one, it will give you the margin of error. It's just not the way they want you to do it, probably.
Right.
Right. Okay. Well, does anyone else have anything?
Nope.
Good luck.
Yeah,
luck,
good luck,
everyone.
everyone. We'll
Bye.
see you on
Tuesday.
Tuesday.
Yep.
Over
See
the
ya.
next day, just message and we'll all try to help each other.
Deal.
Great.
Sounds good.
All right.
All right. See ya.
Bye, guys.
Bye.